Okay, so this video is here to explain the process of solving the extra credit problem that I provided you if you wanted to try it in the project. And that extra credit problem would be if you know the launch angle of something and you want to hit a target, then how would you calculate the initial velocity that would have to be for that target to be hit? So what I've got here is a problem where a baseball player's hit a ball and the initial height is 3 feet and with a launch angle of 24 degrees. So let me draw that 24 degrees in. And then what would the initial velocity need to be in order for the batted ball to just hit the top of a 10-foot high output wall 370 feet away? So I've drawn the picture and I've sort of labeled it to give us a little less, a little faster time to go through this. So, when we're dealing with these, we have horizontal and vertical stuff. And in this case, we care about horizontal and vertical distance, not so much the velocity until much later in the problem. So I know I want the horizontal distance to be 370. At the same time, the vertical distance is 10. So first thing I want to do is get the equations for horizontal and vertical distance. Now, horizontal distance is normally 0 acceleration, t squared, and there's that 1/2 in front of it normally, plus vx naught t plus 0. So that's normally Vx naught times t. But in this case, we don't know what Vx naught is because we don't know what V naught is. But the way we normally calculate that is by doing the SOHCAHTOA thing. So we're using the cosine. So really, Vx naught is V naught, the initial velocity, times the cosine of the launch angle, which is 24 degrees, all that times t. Now, that's the equation for the horizontal position. And notice, we want the horizontal position in this problem to be 370. We want it to go 370 feet when it's 10 feet high. So this is the 370 part of it. Notice this equation still has two unknowns in it, V naught and t. So now we're going to look at the same information but from the vertical perspective. So y of t is normally 1/2 times negative, and in this case we're dealing with feet, so it's going to be negative 32 t squared plus v sub y naught times t plus the initial height, which in this case is 3. Now, in this case, 1/2 times negative 32 is negative 16. And we don't know Vy naught, and we can't really calculate it, again, because we don't know V naught, but we can say that V naught times the sine of 24 degrees is V sub y naught. So it's that times t plus 3. And we know that height, we want it to be 10 at the same time that this is 370. So I've got 10 is this vertical height, and these times in these two equations that I've got are the same. All right, so what I've got here is an equation with two unknowns, V naught and t, and another equation with two unknowns, V naught and t. So what I'm going to do here is a system, and this is a complicated system. We don't want to try to do elimination or anything like that. We're going to try to just do substitution. So if you look at this equation over here, it's the more complicated one. So substitution would be much easier to solve this horizontal equation for one of the variables. So I'm going to do that. And if you look at the more complicated equation, if I solved this simpler one for t, I'd have to plug it in two places. So I'm going to solve this thing for V naught instead. So in order to get V naught by itself, I would divide both sides by the cosine of 24 times t. So now that I know what V naught is, I can take that, substitute it in there, and I get something that looks like this. I had V naught, but I don't want V naught now. I'm going to replace that with what V naught equals, 370 over the cosine of 24 degrees times t, times the sine of 24 degrees that was sitting there times a t plus 3. So now what I've got is an equation that has nothing but t's in it, but we really need to clean this up before we do any math on it. So I'm going to look at this middle term. You see how I have a t here? All this stuff is basically over 1. I have a t on the bottom, I have a t on the top. So those t's are going to cancel. So that means that this middle term, 370 times sine of 24 divided by cosine 24, is all a single number. So if I take my calculator and actually calculate that, that's going to give me, let's see, I did this before. Let me pull my calculator over here so I can pull it up again. Doo-ba-doo-ba-doo-doo-doo. That's going to give me 164.734-ish. Dot, dot, dot. And I would use the whole decimal on this for the rest of it. Now notice this doesn't have a t in it, and neither does this. So I can combine those. Negative 16t squared plus 167.734 dot, dot, dot. And I want to solve for t. So the t squared is the only thing that's there. So I'm going to take this 167, blah, 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 and subtract it from both sides. And that's going to give me negative 157.734 blah, blah, blah equals negative 16t squared. I divide both sides by negative 16. And that's going to, oof, boy, it's just getting messy, isn't it? My handwriting is just terrible. That'll give me t squared equals 9.858 and so forth. I take the square root of both sides to get that solution. And technically, I should get a positive or negative number here, but really I only care about the positive time, the part that happened after it actually launched. And I get 3.1398 dot, dot, dot. So that's the time that it takes to reach the outfield wall. So now if I want to know the initial velocity, I've got the initial velocity here in terms of time. So if I do initial velocity is 370 over the cosine of 24 degrees times this time, that would give me 128.99, and that is in feet per second. So this is the initial velocity that the ball was hit from, and I would also want you to find the maximum height, and I want you to find the final velocity on this one. You already would know the range because it was given in the problem, and you would already know the hang time because we found it right here. So really all you have left is to do maximum height and velocity, and you know this initial velocity. So that's how you do the extra credit problem, and you can choose to do this or choose not to do it, but whichever you want to go for it.